We are going to do Lewis structures for covalent compounds. We're not going to do these for ionic compounds because there's a complete transfer of electrons, but we are going to do these for covalent compounds because the electrons are shared, whether they are shared equally, like in a nonpolar covalent bond, or unequally, like they are in a polar covalent bond. All right, so what we're starting out looking at are the rules for determining Lewis structures. Okay, so the first thing we want to do is to determine the arrangement of atoms in the molecules. Basically, one of the atoms will be what we call the central atom. It goes in the middle, and then we will put the other atoms around it. Carbon, because it has the four valence electrons, can have four atoms around it. So carbon's a central atom if you ever see carbon in a compound. And then there are some other ones, and what will be helpful is when we get a little bit further in this and I show you the list of atoms that can never be central atoms. Okay, we are going to count our total valence electrons, and remember those are the electrons that are on the outside, the outer shell. And if our atom is in group 1, 2, 3, 4, 5, 6, 7, or 8, then remember the group number tells us the number of valence electrons. For polyatomic ions, each negative charge means that we will add one electron. All right, and each positive charge means that an electron was removed. So if it had a -2 charge, then after you counted the valence electrons around the atoms that make up the polyatomic ion, you'll just add 2. And if it was, let's say it was a +2, you would do the opposite. You would subtract. Okay? You're going to subtract 2 electrons for each bond from your total. And that will be the bonds that you make when you when you connect the central atom to the terminal atoms. Think back to what we were doing yesterday when we looked at difference in electronegativity, and you had like C-8. That dash is the bond. We will add lone pairs of electrons around the terminal atoms to complete their octets. Except for hydrogen, which can only have 2 around it. If there are any remaining electrons after all the terminal atoms are complete, they go on the central atom. Okay, and they will do that as lone pairs. If the central atom does not have an octet, we will have to borrow electrons from carbon, nitrogen, oxygen, phosphorus, sulfur to form double or triple bonds. And then this is what I was telling you here. And so I want to highlight this part where hydrogen, fluorine, chlorine, bromine, iodine can never form double bonds. So basically hydrogen and your halogens. And central atoms with fewer than 4 valence electrons may not obtain an octet. Okay, so those are some rules for you. And then if it's a polyatomic ion, we will put brackets around them, and we'll put the charge as a superscript. So this is a lot, but the good thing is we're going to go through all of these rules with examples. All right. So the first set of examples, and you can see this, you have group A, simple molecules. You see other groups, polyatomic ions, multiple bonds, incomplete octets, expanded octets, multiple central atoms. Okay, and then there's some independent practice. So you can see how we're gonna work together, and then we're gonna do some work independently. So let's start with our simple molecules.